In this problem, we'll solve a system of equations using the elimination method. We'll solve the system x minus y equals 6, 3x plus y equals negative 2. To solve the system using the elimination method, we add, sometimes also called the addition method, and we're going to add in a way that will eliminate a variable. Looking at these two equations, I notice that the coefficient of y in the first equation is negative 1. The coefficient of y in the second equation is positive 1. If I add the left sides and the right sides together, I will have 0 for the coefficient of y, which means I will have eliminated that variable. Let's add them together, and I'll line the variables up here. Here I have 3x plus y equals negative 2. I add, and I have x plus 3x is 4x. And here's where I have, you can think of this as negative 1 times y plus 1 times y. That's like plus 0. And that equals 6 plus negative 2, which is 4. I've eliminated the y. This gives me 4x equals 4. Dividing both sides by 4, I have x equals 1. Now I haven't solved the system yet. I've only found the x, and I need an x and a y in ordered pair. In order to find y, I need to substitute 1 for x in one of these equations and solve for y. It can be either equation that you want to choose. I'm going to use the second equation because here y has a coefficient of 1 and it should be easier to solve for. So I substitute 1 for x here. I have 3x plus y equals negative 2. Substituting 1 for x gives me 3 times 1 plus y equals negative 2. 3 plus y equals negative 2. Subtracting 3 from both sides, I have y equals negative 5. Here is their x value. Here's the y value. I form the ordered pair by using the x first because it comes first alphabetically, 1, comma, negative 5. Now, is that the solution of the system? Well, substitute it in both of these equations. If it makes both equations true, and it does, it is the solution of the system. So the solution of the system is the ordered pair 1, negative 5.